there wasn't any network segmentation for like IoT devices. Like as I said, these days it's like if would try and contain like the IoT devices on like a guest network and
Right.
use 802.11.x authentication. Once they authenticate, then it basically gives them a VPN ticket into the inside of the network. Whereas like the IoT devices, I would permanently imprison on an IoT network. Because I don't care if you bring your Alexa speaker, but yes, these may be very popular, like Raspberry Pi, Odroid, stuff like that. A lot of people will retro game with them. Yay! I've also seen stuff that's designed like pen testing software kits that are designed to look like they're a retro game from yore that run on these, so they don't look suspicious unless you're looking for them. So IoT devices can be lovely. You know, get these plugged into your network. Select the Wireshark and upload data to the cloud. What could be wrong, right? I've seen I've seen pen test kits that look like literally somebody that's running a Game Boy emulator. Until you look at it, oh, this attack, Fraggle attack, spoofing attack, phishing.
And it all comes preloaded.
Yes, but to the average clueless, user, it literally looks like somebody like loading a Game Boy game. The screens look just like it. And, Docker, it has some secure uses and some insecure uses, and microservices and containerization. They're a boon for security, but they also have their own security woes as well. The nicety in theory of Docker is that if someone fucks them up hard enough and bad enough that they'll just implode. But when it implodes, it basically causes the whole thing to respawn clean, meaning if there was any infection in it, it disappeared. But
In
if
theory.
I'm saying in theory, of course, but yet if there was a particular vulnerability that they had injected while, crashing the thing, then they can then pretty much inject arbitrary code into your nice kernel and bypass everything. And, you're not having a good day, but they are. But if Docker is running right, then basically Docker's like, I don't know what to do with this, crash, respawns, or the Kubernetes just kicks them off the container and moves them to the container, crashes that one, and then spins up a new copy. Yay for, containerization orchestration services. Yay. But at the same token, people have to layer the security just right to use these containers extremely effectively. I mean, they lab just right, but then, certain other features, need to be done. Some places are now using like edge computing systems to speed stuff up, like, CASB appliances or stuff like that. Virtualized systems, distributed systems, etc. I mean, cryptography systems, people have seen for like the old cryptographics accelerators for like web servers for years. Those have kind of gone away for like crypto accelerator cards, especially for like high pressure web servers. Ow, God. But database systems and so forth, and industrial control systems. Shodan is the way.
Mm-hmm.
Nuclear power plants, anyone?
Yeah, my business partner was a nuclear radiation control officer on a nuclear submarine.
Hey, yeah, but how would you like your nuclear submarine to be connected to the interwebs and explorable by Shodan? Probably not.
Probably not. Yeah.
But, some of the civilian shit is. And Shodan, you can, look at all kinds of stuff here. Like literally some of the stuff from, you want to look at GE and nuclear power? Be my guest. Shodan will find them. If it's a nuclear power station like 3 Mile Island, hey, what could possibly go wrong?
Yeah,
Hey,
Shodan's terrifying.
This is why we still play the movie War Games, so people are situationally aware.
Mm-hmm.
oh, I just referenced that not too long ago with the in-laws. It's like he goes, well, my brother doesn't do anything for my dad and brother. I'm like, the only way to win is not to play the game. He knows that both of them are getting decrepit, and there ain't shit you can do for them. The more you keep trying to help them, the more you're just not putting them in the home that they need to. But cryptographic systems, which pretty much what kind of needs you need, like key
Mm-hmm.
systems, public key. Everybody's familiar with RSA. Uh, Cryptographic methods, elliptical curve, asymmetric. And now you have quantum keys.
It's scary.
Well, the quantum keys aren't too scary, and they've gotten a little bit better at their robustness, because like one of the first quantum algorithms that was done was for most of your quantum algorithms that are mostly available now are point-to-point quantum algorithms. If you splice the fiber optic cable, the other two parties know. So if you don't like set up a fix or tune the cable just right so it can continue, then people are having a bad day, because the quantum tunneling thing basically sees if the cable's spliced into and if it's being man in the middle or not. There's more than the end-to-end places. Like if you have a router that's using a fiber optic cable and your ISP is using a fiber optic cable, the encryption's not happening between yours and their site, and then basically then changing encryption over from, like, say, your office here, your local office, and then your office in San Francisco. If there's a man in the middle, someone tries to splice into the fiber and sniff data, then basically all the packets become garbled and corrupted. Then basically immediately throws an error. They had a hack for it a few years ago where someone could break in and then reassemble the packets, but then they improved the key strength and retweak the algorithm. So the quantum cipher on that particular one is meant mainly for like fiber optic cables, and point-to-point data encryption for just shipping data over the pipe. But with quantum encryption, the why the places like the NSA are worried about it is because you can have basically a one-time quantum pad level encryption that's virtually unbreakable.
Right.
because basically it can establish two keys between two things. And like they've had, quantum machines that they've had math problems that haven't been broken for 6,400 years just fall to pieces within under 30 minutes.
Yeah, that's what's scary about it to me. So as soon as we get enough qubits, then encryption programs are going to have to be rewritten.
Which is why they've gone to like SHA-3. They're trying to go to SHA-3, which is a bubble block cipher, which is much more harder to do with on a quantum level. So, but yeah, a lot of your classic encryption that uses two very large primes will have to be refactored in such a way that there's maybe 5 or 6 primes involved.
Right.
So it'll be much more significant and difficult to break, and/or smaller layers of encryption, and then basically a thin layer of encryption, a medium layer encryption, and then basically a thicker layer of encryption, and a nest, basically nested AES in such a particular offshooting pattern that's more difficult to factor. But key management practices is kind of key. Some keys like PGP, 5 years is good enough to keep them. In some cases, if they're hardened enough, some depending on the policy and procedures, PKI infrastructure, most places keys are held for a year or two. Depends on how thick your keys are. Digital signatures and digital certificates, they're good for non-repudiation, integrity, and hashing and so forth, and good for email. Plus, if you've ever managed Active Directory, if you don't have a good PKI structure, it don't work.
Mm-hmm. Hopefully quantum keys won't be on the test.
There may not be, there might be, is quantum encryption valid or true or false? I don't know, but
Mm-hmm.
may not be that technical about how the quantum keys are doing. I'm just saying for your edification, the most quantum keys I've seen is basically for like a hardware fiber optic router to hardware fiber optic router. Basically, it'll say here, understanding methods of crypto-analytic attacks, brute force,
Mm-hmm.
fault injection, timing, man-in-the-middle past the hash, chosen ciphertext, implementation attacks, and side channel, and like ransomware.